Hey Opties! Today we're looking at difference of squares. This is a type of factoring when you have a specific situation in your standard form quadratic. So let's take a look at our definition. If a standard form quadratic has a b value of 0, which means it has no x term at all, a is a perfect square, and c is a negative perfect square, which doesn't mean that the perfect square itself is negative, it's just subtracting a perfect square. Then you have what is called a difference of squares. Remember, the word difference means it's a subtraction, and the squares means that each piece is something squared. So we have y equals ax squared minus c, where a and c are perfect squares. So that's the situation. This is a standard form quadratic representation. A point to ponder is a perfect square is a number that has two factors that are the same number. A perfect square is a whole number if you take the square root of it. So that's how you can check to see if a number is a perfect square. So if you see a number times x squared, or just simply x squared, minus another number, and you're trying to see if it applies to the difference of squares rule we're going to learn, then you can simply take the square root of that number and see if you get a whole number. If you do, that's the number you need to use for your formula for difference of squares, and that will tell you if it is a perfect square. So perfect squares are not that mysterious. Think about 4. Well, what's the square root of 4? That's 2, because 4 can be written as 2 times 2. Other perfect squares are 64, that's 8 times 8, or 89, which is 9 times 9, or 144, which is 12 times 12. So those are some perfect squares, just to remind you what those look like. Here's our formula. We're going to rewrite ax squared minus c as a squared minus b squared. This just makes it a whole lot easier to apply our little formula or our little trick. It's like a factoring trick. It's like a shortcut, basically. And it's not like you're doing anything crazy. It's the real math. This statement is true, and because it's true, you can go ahead and apply the square root of a is going to be a, and the square root of b is going to be b. Once you know those, you can just add those two together for one of your binomials, so one of your factors, and then you can subtract those two for your other binomial. So that is the rule, and let's see by using the distributive property that this truly does equal a squared minus b squared. So a times a is a squared, and then we have negative ab, a positive ab, which you could write as BA as well. And then you have a negative B squared. Okay, so negative AB plus AB is a 0. And then you're left with A squared minus B squared. So you can see how they do match, and that's how we can use that shortcut when we factor difference of squares. Let's take a look at some practice. We want to factor this quadratic that's x squared minus 89. So the question is x squared a perfect square, and is 89 a perfect square? So what is the square root of x squared? That's just x, okay? And what's the square root of 89? That's 9. So they are perfect squares. So these are the a and the b that we need for our formula. So remember, a squared minus b squared is equal to a plus b times a minus b. So let's just substitute our a and b into this formula and we're done. It's that easy. So y equals a, which is x, minus b, which is 9. And now we're going to add them, x plus 9. And actually I swapped the order that I wrote here, but remember, it doesn't matter because multiplication is commutative. And these two binomials, the things in parentheses, those are being multiplied together. Number 2. Factor the following quadratic, which is y equals 9x squared minus 16. So one thing you could try to do is find the GCF. So let's think 9 is 1 and 9, and then 3 and 3. And 16 is 1 and 16, 2 and 8, and 4 and 4. So notice they don't have anything in common except for 1, and you can't factor out a 1, it's just going to stay the same. So GCF is not going to help us anyway, but we need to check, is it a difference of squares? So let's check our 9x squared and our 16 and see if they're perfect squares. you take the square root of 9x squared, you get 3x. So that part works. Taking the square root of 16 is 4. So that works as well. And we could see that we have our doubled factors here. We could tell they're perfect square from looking at listing our factors. So here's what we need for our A and our B to use our formula. So y is 3x plus 4 times 3x minus 4. And that's all you have to do. That's it. You've completely factored this quadratic. All right, Opties, that's it for difference of squares factoring. See y'all next time.